Day 146, Physics Circuits homework, problem number 2C. This is another fairly straightforward problem. You could draw the new diagram, which we've been doing. In this case, what you would do, you would calculate the combined resistance of these two resistors in parallel. That'd be 1 over their total resistance equals 1 over 3 plus 1 over 6. Their combined resistance would be 2 ohms. So the diagram would just look like this. It's a one-step problem. 6 volts, 2 ohms, and then applying Ohm's law, you could get the current in this circuit, V equals IR. So we have 6 equals I times 2. So the current in this circuit is 3 amps. So I could show that here. That represents current flowing everywhere, not necessarily, not starting at the battery, just being pushed by the battery. Or going to this other diagram at the top, I have 3 amps, I just figured it out, 3 amps of current in that part of the circuit, right by the battery. That current is going to this spot right here and then splitting up. Some of it's going across this way, and some's going around that way. Most of it goes through that middle branch because that's half the resistance. It'll get twice the current. Then it comes back together over here as 3 amps. So we can take that, say the 6 ohm resistor. So V for the 6 ohm resistor equals I times R for the 6 ohm resistor. Its voltage is 6 volts. It's attached directly to the battery. They're independent of each other. They are in parallel. If one goes out, the other one stays on. We don't know what its current is. They have the same voltage in parallel, not the same current. The resistance is 6, so the current here is 1 amp for that 6 ohm resistor. And then for the 3 ohm resistor, you have its current times R. We don't know what the current is. We know it's 6 volts. Once again, it's connected directly to the battery. And the resistance is 3, so the current is 2 amps. Once again, this all adds up because the 2 amps plus the 1 amp equals the 3 amps. Twice as much current goes through the smaller resistor. You can fill those numbers in to the table there, and once again multiply current times voltage, you get the power that comes out in watts. So fill in the table to finish the problem.